Hello student, greeting of the day. I am Dr. Kavita from MBA department and today we will discuss about probability theory basic concept. Probability is a very important topic of statistics as you all know. Let us start what is probability and why there is need to study probability. Today we will do only some theoretical concepts so that you may be familiar with the basic concept of probability theory. So let us start with probability. What is probability? Why it is needed? Probability is a measure of likelihood of an event to occur. Many events cannot be predicted with total certainty. You can't predict everything because you all know future is always uncertain. But for making some decision, you need to require to some prediction about the future. We can predict only the chance of an event to occur, i.e., how likely they are to happen using it. With the help of probability, we can predict that what can be the chance of an event to occur. Probability can range from 0 to 1, where 0 means the event is, to be an impossible one, means there is no possibility of occurrence of an event, and 1 indicate a certain event, means definitely that event will occur. For example, when we toss a coin, either we got head or tail. Only two possible outcomes are possible, as you know, because only two events are possible here, head and tail. But if we toss two coins in the air, there could be three possibility of event to occur, such as both the coin show head or both the show tail, or one show head or one tail. So if we toss two coins, then there may be chances of three events like HH head head, HT head or tail, and TT tail tail. Formula for the probability, there is a formula to find out the probability. The probability formula is defined as the possibility of event to happen is equal to the ratio of the number of favorable outcome and the total number of outcomes. So we can write the formula like this: probability of E means event, is equal to M divided by N, where PE means probability of event to happen, M means number of favorable outcomes, and total number of outcome. So let us check a simple application of probability to understand it better. Suppose we have to predict about the happening of rain or not. The answer to this question is either yes or no. There is likelihood to rain or not rain. Here we can apply probability. Probability is used to predict the outcome for tossing of coin, where you can use probability, like for tossing of coin, rolling of dice, and drawing a card from a pack of playing card. Then there are some terminology which are very important to know before going further description of probability. There are some terminology, there are some concepts which need to know. First, experiment. What is experiment? A trial or an operation conducted to produce an outcome is called an experiment. And then sample space. All the possible outcome of an experiment together constitute a sample space. For example, if we toss a coin, then sample space will be head and tail. Then favorable outcome. An event that has produced the desired result or expected event is called a favorable outcome. For example, when we roll two dice, you all know what is dice, right? So the dice which we use in Ludo game, and it have 6 faces, 1, 2, 3, 4, 5 and 6. Then for example, when we roll two dice, the possibility or favorable outcome of getting the sum of number on the two dice are as 4 are. Suppose you want to know the probability of sum of 2 when we roll 2 dice. So there may be possibility 1 on one dice, 3 on other dice, 1 plus 3, that is 4. 2 on first die, 2 on second die, 2 plus 2, that is 4. And 3 on first die, 1 on second die In this way we can have 3 favorable outcome for getting 4. Then trial. What is trial? A trial denote doing a random experiment. Then random experiment, an experiment that has a well defined set of outcome is called random experiment. For example, when we toss a coin, we know that we would get a head or tail, but we are not sure which one will appear. We have no idea. Either tail happen or head. Now, event, the total number of outcome of a random experiment is called an event. Then equally likely event, event that have the same chances or probability of occurring are called equally likely events. The outcome of one event is independent of other. For example, when we toss a coin, there are equal chance of getting head or a tail. There is nothing to do with like in first time we got head, in second time we will get tail. It's not like that. We can have in second time also head and in first time as well. Then exhaustive event, when the set of all outcome of an experiment is equal to the sample space, we call it an exhaustive event. Then mutually exclusive events, event that cannot happen simultaneously are called mutually exclusive event. For example, the climate can be either hot or cold. It can't be hot and cold at a time. It can be either hot or cold at one time. We cannot experience the same weather simultaneously, right? Then let us start with some example. We will start with coin toss probability. Let us now look into the probability of tossing a coin. We will start with one coin, then we go for 2 coin, tossing of 2 coin, and then 3 coin. So that you will be able to more familiar with the concept of probability with the help of the real life example. Let us now look into the probability of tossing a coin. Quite often in a game like cricket, as you all know, in game of cricket, which team bat or which team bowl, it will depend on the tossing of coin. And quite often in game like cricket, for making a decision as to who would bowl or bat first, we sometimes use the tossing of a coin. I think mostly time use the tossing of coin and decide based on the outcome of that toss which team will bat or bowl. Let us check as how we can use the concept of probability in the tossing of a single coin. Further, we shall also look into the tossing of 2 and 3 coming respectively. So, first let us start with tossing of single coin. A single coin on tossing has 2 outcome, as you all know, a head and a tail. The concept of probability, which is the ratio of favorable outcome to the number of outcome, total number of outcome, can be used to find out the probability of getting the head and the probability of getting the tail. Here, total number of possible outcome is 2, one is tail, second is head, and sample space you can see H and T, that is head and tail. And probability of getting head, that is 1 by 2, because number of head is 1 and total outcome is 2, and probability of getting tail is also 1 by 2 because number of tail is 1 in case of tossing of one coin, and total outcome are 2, one is head, second is tail. Now let us do what can happen in tossing of 2 coin. Tossing 2 coins. In the process of tossing 2 coins, we have a total of 4 outcome. The probability formula can be used to find out the probability of 2 head, 1 head, 1 head, no head, and a similar probability can be calculated for the number of tails. The probability calculation for 2 head are as follow. Total number of outcome is 4. So, sample space is, what can be sample space? We can have 2 head HH, we can have first head and second tail, we can have first tail and second head, and we can have both tail, first tail and second tail. So, in this way we have total number of outcome is 4. Then probability of getting 2 head is equal to probability of getting 0 to, definitely if we get 2 head, definitely a tail will be 0. Then number of outcome with head divided by total outcome, that is 1 divided by 4. A probability of 2 head and probability of 0 tail will be equal. Then probability of getting 1 head and probability of getting 1 tail will be same. Number of outcome with only 1 head divided by total outcome. So we have two outcome where we get only 1 head or only 1 tail. So the probability will be 2 divided by 4, that is sorry, 1 by 2. Then probability of 0 head or 2 tail, number of outcome with 2 head divided by total outcome, that will be 1 by 4. So in this way we have done tossing of 1 coin and tossing of 2 coin. Now suppose we have 3 coins, tossing 3 coins. The number of total outcome on tossing 3 coins simultaneously is equal to 2 power 3, that is 8. For this outcome we can find the probability of getting 1 head, 2 head, 3 head and no head. A similar probability can also be calculated for the number of trials. Total number of outcome 2 power 3, that is 8. So sample space will be we can have 3 head H, we can have 2 head and 1 tail H, T, and we can have first head then tail then head, so that is H, T, H, and in fourth we can have first tail then head then head. Then in fifth we can have tail then head, and in this way tail, head and tail, and in seventh head, tail, and in last we can have 3 tail. So what can be the probability here of 0H and 3T? Probability of having 0H, no H, and having 3 tail will be same, number of outcome with no head divided by total outcome, because number of outcome with no head means there are only tails. So it will be 1 divided by 8, because there is only one case where we have 3 tail and no head. And then probability of having 1 head and 2 tail, number of outcome with 1 head and 2 tail, you can see in the sample space we have 3 outcome having 1 head and 2 tail, right? Like you can see 5th one, 6th one and 7th one. So probability will be 3 divided by 8. Then probability of having 2 head and 1 tail, the number of outcome with 2 head divided by total outcome, it will also same 3 by 8, you can see in the sample space. And last is probability of having 3 head and no tail. Probability will be same, number of outcome with 3 head divided by total outcome, that is 1 divided by 8. So it's about tossing of coin. Now let us come to dice roll probability, because we use dice also in probability. Many games use dice to decide the move of players across the game, like in case of Ludo game. After rolling of dice, it is decided that player who play in the game of Ludo. A dice has 6 possible outcome, you all know, and the outcome of a dice is a single game of chance and can be obtained by using the concept of probability. You have to roll dice and you can get your outcome. It may be 1, 2, 3, 4, 5, 6. As you all know, there are total number of faces on dice are 6. Some games also use 2 dice and 3, and there are numerous probability that can calculated for outcome using 2 dice. Let us now check the outcome, their probability for one dice and two dice. Let us start with one dice, rolling one dice. The total number of outcome on rolling a die is 6, you all know, and the sample space is 1, 2, 3, 4, 5, 6. Here we shall compute the probability of following few probability to help in better understanding of the concept of probability on rolling one dice. So, probability of even number, you can see even number like 2, 4 and 6 is even number, are even number in this sample space. So, favorable cases are 3 and total cases are 6. So, probability of getting even number will be 3 by 6, that is 1 by 2, and in the same manner probability of getting odd number is also same, because we have 3 odd number 1, 3 and 5. So, probability of getting odd number is also 3 by 6, that is 1 by 2, and probability of getting prime number, you know, the prime number here, you know, what are which are the prime number 2, 3 and 5, because 1 is not a prime number, right, and we have 3 prime number 2, 3 and 5. I hope you know the what is the prime number. Prime number is the number which can be divided either by itself or by 1 only, right. Then come to rolling of 2 dice. Sometimes we have 2 dice, we can roll 2 dice, then there is little difference in getting the outcome. So, the total number of outcome on rolling 2 dice will be 6 power 2, 6 square, that is 36. You can see this image to find out how 36 outcome will occur. Here number on the second die is given above and number on first die given in this side. You can see the 2 arrow, blue arrow and light color arrow. So, here you can see 6 face on first die, 6 face on second die, and you can see the combination in 36, like you can see combination 1, 1, right, 1, 2, 1, 3, 1, 5, 1, 1, 4, 1, 5, 1, 6. In the same manner 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 5, 4, 5, 4, 6, and 5, 1, 5, 2, 5, 3, 5, 4, 5, 6, 5, 5, 5, 6, and in the same manner in last row you can see 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. In this manner we have total number of outcome, that is 36, and we can find out the probability of different events. Let us check a few probability, because there are many outcomes. We will check only few probability of outcome from 2 dice. The probability are as follow, like suppose probability of getting it doublet, same number, right. So, you can see, I am coming to last slide, you can see how many doublet. You can see 6, 6, 5, 5, 4, 4, 3, 3, 2, 2 and 1, 1, right. Then total total same number, total doublet we have 6, right, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6, and total outcome we have 36. So, probability of getting a doublet same number will be 6 by 36, that is 1 by 6. Then probability of getting a number 3 or on at least 1 dice, right, there should be 3 at least on 1 dice. Again we move to previous slide. You can see one slide 3, you can see 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10 and 11. So, we have total outcome 11. So, probability of getting a number 3 on at least 1 dice, it will be 11 by 36. In this manner, you can have different kind of example, you can do different kind of example on this basis. Then probability of getting a sum of 7, come to the previous slide again, sum of 7. You can see in first column 6 plus 1 is 7, 1, then 5 plus 2 is 7, 2, then 4 plus 3, then 3 plus 4, then 2 plus 5, then 1 plus 6. So, we have total 6 outcome where the total is 7. So, probability of getting a sum of 7 is 6 by 36, that is 1 by 6. As we see, when we roll a single die, there are 6 possibility. When we roll 2 dice, there are 36 possibility. When we roll 3 dice, we get 216 possibility, 216 possibility. So, a journal formula to represent the number of outcome on rolling n dice is 6 power n. So, in this way, we can solve different kind of example on the basis of rolling die. Now, come to probability of drawing cards. As you know, cards are also used for probability. You all know the playing cards, right? A deck containing 52 cards, total number of cards in a deck is 52, is grouped into 4 suit of club, diamond, heart and spade. There are 4 suits, one of club, one of diamond, one of heart and one of spade. And in each suit there are 13 cards. Each of the club, diamond, heart and spade have 13 cards each. You can check in your home if you have cards, and you can do the example with the help of cards, which sum up to 52. Now, let us discuss the probability of drawing card from a pack. The symbol on the card are shown below. There are symbol, you can see the card, spade, club, black card, heart and diamond, a red card, and the 13 card in each suit. Starting from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, because we have 4 face card, ace, jack, queen and king. In these, the jack, the queen and the king are called face card. We can understand the card probability from the following example. There are some example because we can have number of example in case of card. So, let us do some example so that we can be able to understand the concept of probability using cards more clearly. So, let us start with some examples. Suppose the probability of drawing a black card means probability of black card will be 26 divided by 52, because we have 26 black card and we have 26 red card in a deck of card. Then the probability of drawing a heart card, as we know we have 13 heart card, total number of card of heart are 13. So, probability of getting a black card will be a heart card will be 13 divided by 52, that is 1 by 4. Then we can know the probability of drawing a face card. As you know, we have total number of 12 face card, jack, queen and king. So, there are 4 jack, 4 queen and 4 king in total 52 cards. So, we have total 12 face card in a deck of cards. So, the probability of getting a face card will be 12 divided by 52, that will be 3 by 13 after calculation. Then the probability of drawing a card numbered 4, it will be 4 divided by 52, because we have 4 card of number 4, we have 1 club of 4, we have 1 diamond of 4, we have 1 heart of 4 and we have 1 spade of 4. So, we have total 4 cards of having number 4. So, probability will be 4 divided by 52, that will be 1 divided by 13 after calculation. Then the probability of drawing a red card numbered 4. We have only one card, we have only two card which are red and which are of 4, numbered 4 and having the color red. So, the probability will be 2 divided by 50 to 1 divided by 26. So, in this way, this is the references which you can go through, and this all about the theoretical aspect of probability. We will do next concept of probability like theorem, addition theorem, multiplication theorem, Bayes theorem, etc. in next lecture. So, for today, thank you.